Hello everyone, I'm John Magas, your teacher in Precalculus. And today, I'm going to teach you about circle. When we talk about circle, it's a set of all points on the plane equidistant from the fixed point called center. And the distance from the fixed point that is center to any point in the circle is what we call radius. And later on, I'm going to show you how to solve problems involving circle. So in solving circle, it's very important to determine whether the equation is in standard forms or in general form. So this one is written in standard form. So circle with center at the point of origin, the equation is x squared plus y squared equals r squared, where r is the radius, while if the center of the circle is h and k, then the equation is x minus h squared plus y minus k squared equals r squared, that is in standard forms. While if the equation is in general forms, so we have a circle with center 0 and 0, that is like x squared plus y squared minus r squared equals 0. Take note that this one is always negative. So we have x squared plus y squared minus r squared equals 0. This one is negative because if we're going to transpose this one to the right, it will become x squared plus y squared equals r squared. While if r is positive, that means x squared plus y squared plus r squared equals 0. If we're going to transpose this one, it will become x squared plus y squared equals negative r squared. This one is not acceptable because the radius is negative. Take note that radius is always positive. Next is circle with center h and k. So we have x squared plus y squared plus dx plus ey plus f equals 0. D, E, and F are constants. This time, I'm going to show you how to solve problems involving circle. Example, determine the center and the radius of the circle whose equation is x squared plus y squared equals 36. So let's try to solve. The equation is x squared plus y squared equals 36. So this equation is written in standard form. That means the center is at the point of origin, that is 0 and 0. So we have here 36. That means r squared equals 36. We are going to solve for r. Get the square root. It will become r equals 6. So let's try to graph. The graph looks like this. We have center is 0 and 0. So from center, we're going to count 6 units to right, upward, to the left, and downward. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So our circle looks like this. Another example, determine the equation of the circle whose center is at the origin and the radius is 3. So I think it's a very simple problem. The center is at the point of origin, that means 0 and 0. So the radius is 3. And to graph this equation, the center is 0 and 0, the radius is 3. So 1, 2, 3, 1, 2, 3. So the circle looks like this. Next example, determine the center and the radius of the circle whose equation is x minus 2 squared plus y minus 3 squared equals 25. So we have x minus 2 squared plus y minus 3 squared equals 25. That means the center is 2 and 3, while r squared equals 25. That means r equals 5. So let's try to graph this one. The center is 2 and 3. So we have 1, 2, 1, 2, 3. That's center. Next is 5. So 5 units to the right. 1, 2, 3, 4, 5. 5 units upward. 1, 2, 3, 4, 5. And then 5 units to the left. 1, 2, 3, 4, 5. 5 units downward. 1, 2, 3, 4, 5. So we have so the circle looks like this. My example is determine the equation of the circle whose center is -3 and +2 and tangent to the y-axis. We have x minus h squared plus y minus k squared equals r squared. So in our problem, center is -3 and 2, and then tangent to the y-axis. So one way to solve this one is to graph first. So we have -3, 1, 2, 3, and +2, 1, 2. So the center is at this point. Tangent to the y-axis, that means the circle touches the y-axis at only one point. So the circle looks like this. Assuming that the circle touches the y-axis at only one point, let's say at this point. So we have -3 and +2. We're going to write it in this form. So we're going to determine the radius. So from the center, we have 1, 2, 3. That means r squared equals 3 squared. That is r squared equals 9. So the equation is x minus -3 and then squared plus y minus 2 equals 9. But -3 times negative is positive. That means we have x plus 3 squared plus y minus 2 squared equals 9. This is now the equation of the circle. Last example, determine the center and the radius of the circle whose equation is x squared plus y squared plus 6x minus 4y equals 12. This equation is written in general form. So to determine the center and the radius, we have to transform it into standard form. That is x minus h squared plus y minus k squared equals r squared. So first is arrange the equation to become x squared plus y squared plus 6x minus 4y equals 12. So x squared plus 6x plus y squared minus 4y equals 12. And by completing the square, it will become x squared plus 6x plus blank plus y squared minus 4y plus blank equals 12. So we're going to divide 6 by 2 and -4 by 2 and then square the quotient. It will become x squared plus 6x. 6 divided by 2 is 3 and then squared plus y squared minus 4y plus -4 divided by 2 is -2 and then squared equals 12. Then it will become x squared plus 6x. 3 times 3 equals 9 plus y squared minus 4y. -2 times -2 equals 4 equals 12 plus 9 plus 4. And then notice that this equation is perfect square trinomial. It can be written as x plus 3 and then squared plus this equation is another perfect square trinomial. It can be written as y minus 2 squared equals 12 plus 9 plus 4 is 25. This is now the standard form of the equation. And this time, we can determine the center and the radius. So we have c, that is -3 and +2, and the radius is 5. And this is now the center and the radius. And to graph the equation, we have center, that is negative 3 and 2, and the radius is 5. So negative 3 and then positive 2. From the center, we're going to count 5 units to the left, 5 units upward, 5 units to the right, and 5 units downward. So from the center, we have 1, 2, 3, 4, 5. This point, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So the center looks like this. And that's all for today. I hope you learned something, and despite all of this pandemic, we are trying to do our best to deliver to you our lesson. Keep safe, everyone.